Everest, Earth's highest mountain, needs no introduction. At 29,032 feet, it sits not only at the top of the world, but at the top of countless bucket lists.
Scientists have just uncovered a startling truth on the summit of Mount Everest. For decades, Everest has been understood as the result of a continental collision that unfolded over tens of millions of years, as layers of rock were compressed and slowly forced upward. Yet hidden beneath the permanent ice on the roof of the world lies evidence that seems almost impossible to believe: the remains of ancient tropical marine life. What makes this discovery so astonishing is not only that these traces appear at the highest point on Earth, but also that many of the fossil structures remain delicate and intact, rather than crushed beyond recognition, as scientists would expect. So what force truly lifted the remains of an ancient ocean all the way to the top of Everest? The answer begins to emerge now. A physical impossibility on the roof of the world. To begin with, we need to understand the physical environment at an altitude of 8,848 meters above sea level. This region, known as the death zone, is not merely a place of bitter cold and thin air. In biological terms, it is the most ruthless and efficient engine of life rejection anywhere on the surface of the Earth. Here, atmospheric pressure drops to only 1/3 of what it is at sea level, a threshold the human body cannot adapt to. Every breath delivers only a tiny fraction of the oxygen required to sustain basic function. The heart rate of a healthy person will surge automatically to around 140 beats per minute, equivalent to intense physical exertion, even while sitting still. Digestion shuts down completely. The brain begins to lose function, triggering hallucinations and destroying the ability to make sound judgments. In essence, this is a biological vacuum, a place where every complex organism begins to break itself down from within. Given such extreme physical conditions, it would seem natural to assume that the summit itself must be built from the most barren and resilient material imaginable, perhaps granite or some form of volcanic mineral hardened over millions of years. But the reality reveals something utterly absurd. At the very tip of the peak, where life is strangled completely, the material forming the summit is not igneous rock at all. It is a massive band of yellow limestone, known to geologists as the Yellow Band, nearly 60 meters thick and packed with the remains of ancient tropical marine creatures. Trilobites, extinct arthropods, delicate crinoid stems, and countless other shelled organisms lie layered together, forming a collective graveyard of a once thriving ocean ecosystem. This is not simply a matter of a few scattered fossil shells that the wind might have carried upward. It is a solid fragment of ancient seafloor, an entire biological structure suspended at the edge of the stratosphere. Before the eyes of climbers and scientists alike, it creates a profound physical collision between two realities. On one side, a frozen biological vacuum, and on the other, undeniable proof of a warm, fertile tropical sea. The contrast is so immense that it challenges the most basic instincts of how we imagine the natural world to be ordered. How could a graveyard of the sea become the very material that built the roof of the world? This mass of rock is itself a physical question, an anomaly fixed into the highest point on Earth, exposing a paradox that geological science is still struggling to fully explain. The preservation paradox inside a geological crushing machine. The absurdity of finding this limestone mass on the summit immediately raises a difficult physical problem, one that standard models of mountain formation cannot easily resolve. Every geology textbook teaches that the Himalayas were created by the long, slow collision between the Indian continental plate and the Eurasian continental plate. Around 50 million years ago, after a long northward drift, the Indian plate began to slam into Eurasia. The process is often described as a car crash unfolding in extreme slow motion, with the layers of the Earth's crust compressed, bent, and gradually thrust upward to create the highest mountain range in the world. In this model, the mountain is the product of tens of millions of years of grinding and compression, a geological crushing machine operating on a continental scale. In such a scenario, anything trapped between these two colossal tectonic plates should have been exposed to unimaginable pressure and heat. The friction and compressive force of millions of cubic kilometers of rock pressing together should have crushed, melted, and transformed the structure of any material caught between them. The soft sediments at the bottom of the ancient Tethys Ocean, where these marine organisms once lived, should have been the first victims of that crushing machine. They should have been heated until they metamorphosed into schist or gneiss, and every delicate biological trace within them should have been obliterated completely, ground into dust. That is what physics and geological models predict. And yet, when scientists examined samples taken directly from the yellow band near the summit of Everest, they were confronted with a physical reality that pointed in the opposite direction. The structures of these fragile marine organisms, especially the trilobites, show no sign of having been deformed or crushed. Their intricate exoskeletons, with all the complexity of their biological design, still preserve astonishing detail. They were not flattened, not stretched, and they show no evidence of being scorched by extreme heat. Their state of preservation is so remarkable that it is almost as if they were buried yesterday in soft mud on the seafloor. For such a mass of fragile organic material to pass through a continental scale crushing system without damage would be like finding an intact porcelain vase inside the core of a block of metal that has been forged and hammered for years. Their existence points to one clear conclusion: the immense friction and pressure described by science did not affect this rock mass in the way we once imagined. And that leaves behind an unsettling question. If it was not lifted by a slow process of crushing and compression, then what physical mechanism brought it here? An isolated biosphere tomb in the death zone. The almost unthinkable intact state of these fossils becomes even more formidable when geologists examine the way they are arranged within the mountain's overall structure. If Everest had truly formed through a slow process of folding, in which an enormous continental sheet bent and rose upward, then this fossil-bearing limestone band should follow a clear geological logic. It should appear as part of a continuous stratigraphic layer, extending from the lower slopes and reaching its highest point at the summit, much like the folds in a sheet of fabric pushed inward from both sides. The different rock layers would transition smoothly, revealing a history of steady and continuous compression. And yet, the detailed geological maps of Everest reveal something entirely different. The yellow band is not scattered or spread gradually from the base of the mountain to the top. It is not part of a continuous folding system. Instead, it behaves like a completely independent physical block, sharply severed from the underlying rock layers and set directly upon the highest crown of the mountain. It wraps around the death zone itself, forming an anomalous limestone cap resting on top of a vast mass of granite and metamorphic rock. In mechanical terms, this is like cutting a delicate layer of sponge with absolute precision and placing it intact on the summit of a skyscraper under construction, without wrinkling it or disturbing its form in any way. This mass of ancient ocean material appears to have crossed thousands of kilometers of the Earth's crust and come to rest at an exact spatial coordinate, creating a physical zone entirely isolated from the rest of the mountain range. The boundaries between the yellow band and the rock beneath it are sharp fault lines, suggesting mechanical separation rather than a normal stratigraphic transition. It carries none of the signs of a slow and chaotic upward squeeze in which layers of matter gradually blend together. On the contrary, it bears the marks of an extremely sharp and directional displacement. It is almost as though an alien body had been inserted into the summit of a pre-existing structure. This arrangement transforms the mountain from a product of accidental collision into an anomalous architecture, where masses of matter do not appear to obey the ordinary logic of gravity and friction. It suggests that some force did not merely push the seafloor upward, but lifted it, moved it as an independent block, and placed it with astonishing precision at the highest point on the planet. The physical traces of violent acceleration. The fact that such a fragile layer of seafloor now sits intact and isolated on top of a colossal mountain forces physics to confront the one remaining variable that could explain this anomaly: acceleration. To move an object as structurally complex and fragile as the yellow band through an environment as dense and solid as the Earth's crust, without crushing it against the surrounding rock, that object would have had to experience an extraordinarily violent upward force, with acceleration great enough to overcome the resisting threshold of friction. If it had moved slowly, friction would have had ample time to grind it away and destroy it. But if it moved at extreme speed over an extremely short span of time, it could pass through other layers of matter before friction had time to act in any meaningful way. This is a basic principle of mechanics, much like the way a bullet can pierce a pane of glass and leave only a clean round hole, while a stone thrown slowly will shatter the entire pane. When geologists studied the bedrock structure directly beneath the yellow band, they found physical evidence that strengthens the case for violent acceleration. The underlying layers show nearly vertical, razor-sharp fractures, with none of the signs of abrasion caused by sideways friction, the scratches and drawn-out deformations that would normally be expected under the theory of slow, continental drift. The physical cuts within the mountain structure suggest that this block of rock was not pushed upward millimeter by millimeter over millions of years. Instead, this material foundation preserves the mechanical traces of a catastrophic impulse, an almost instantaneous release of energy that hurled this seafloor ecosystem straight through the surface of the Earth. It did not slide upward, it was launched upward. The existence of these clean fractures points to a scenario far more terrifying than a continental collision. It suggests that, at some point in the distant past, a colossal energy source from deep below acted upon one specific region of seafloor, tore it free from the Earth's crust, and hurled it skyward with unimaginable acceleration. This rock mass moved so fast that it passed through tens of kilometers of solid stone without being destroyed by friction, before finally driving into the atmosphere and freezing into its present position. This is no longer simply a story of plate tectonics. It is the story of a geological ballistic event, a physical phenomenon that our current models are unable to fully describe or recreate. A mechanical verdict against uniformitarianism. At the very center of this violently accelerated mechanical structure, the familiar body of knowledge that governs how we understand the formation of the Earth and the cycles of modern geology formally loses all ability to defend itself against the pressure of observed reality. For more than a century, textbooks and institutions devoted to natural history have operated within a supreme interpretive framework known as deep time, or uniformitarianism. This core idea built a powerful cognitive barrier in the human mind, persuading us that every transformation of the planet's surface, from the rise of immense mountain ranges to the separation of ocean basins, was nothing more than the result of slow, monotonous, and microscopic processes unfolding across tens of millions of years. That geological tempo spread energy across such a vast timescale that it created an illusion of complete safety, turning tectonic catastrophes capable of tearing apart the crust of a planet into mechanisms that seemed vague, silent, and entirely harmless to the brief span of human life. And yet the colossal physical body, made up of this fully preserved limestone band on the summit of Everest, stands there as a silent but merciless piece of evidence, shattering that reassuring system of interpretation. The combination of the microscopic integrity of these fragile oceanic remains with sharp fracture structures that appear untouched by friction produces an experimental result that cannot be rooted in any model of geological change advancing step by step. If this towering mountain were truly nothing more than the physical product of weary plate motion sustained over 50 million years, then this delicate tomb of tropical marine life could never have preserved its coherent form. Under the continuous grinding of friction and the immense pressures of compression acting across countless tectonic ages, this frozen ecosystem should have been reduced to a band of fine material and reworked into scattered metamorphic minerals buried deep beneath the continental foundation. The physical evidence says otherwise. This mass of material still stands at an elevation of 8,848 meters, preserving its visual sharpness and remaining isolated at that exact height, with the three-dimensional form of every joint in the trilobite's bodies frozen in remarkable clarity. That reality turns the mainstream scientific interpretation of plate tectonics into a theoretical model that functions only on paper, powerless and collapsing when forced onto the exposed material body before us. The climbers driving their crampons into the roof of the world are not, in fact, moving across a mountain structure patiently built by the flow of deep time. Geometry overturns that perception and suggests that they are stepping on the rigid remains of an extreme catastrophe that lifted an entire section of the Earth's crust. The physical existence of this oceanic biosphere mass is presented as the direct mechanical consequence of an instantly destructive physical event. Its structural properties preserve material evidence of a moment when the Earth's hardened crust was shattered and hurled violently into the sky, triggered by a release of energy never classified or acknowledged within conventional geological standards. The fracture boundaries of traditional safe interpretations are pierced open, as the limestone structure demonstrates that the formation of landscapes does not always obediently follow the linear path of slow plate motion. This ocean tomb, hanging at the threshold of near space, stands as proof of catastrophes capable of breaking the continental foundation through brutal and extreme acceleration, exceeding every careful estimate of nature's speed and violence. In that light, the model of deep time is stripped of its power to reassure. In its place, this massive body of material risen from the deep sea becomes a cold affirmation of the laws of mechanics and of the planet's capacity for sudden and devastating force. The entity awakening and the edge of understanding. Science's inability to explain the physical mechanism that gave birth to Everest is now colliding directly with changes unfolding on the mountain in the present day. Everest is not merely losing ice because of climate change. According to recent reports from climbing expeditions and scientists, its core mechanical structure is becoming unstable and collapsing at an anomalous and unpredictable rate. New fractures are appearing in places where none were seen before, and massive ice and rock avalanches are occurring with increasing frequency. The governments of Nepal and China did not suddenly close critical climbing routes, ban solo ascents, and require absolute GPS monitoring for every climber simply because of a few ice falls or concerns about waste. They are responding forcefully to an unpredictable structural rupture within the rock mass itself. If the oceanic tomb on the summit was truly created by a sudden and violent geological acceleration, then that anomalous force may not belong solely to a finished chapter of history. It may be a hidden physical mechanism, a latent source of energy still compressed deep beneath the Earth's crust, and now beginning to show signs of activity once again. In that context, the mountain's cracking in the present moment is no longer just a surface weather event. It may be the sound of an immense geological machine beginning to operate again through brutal physical impulses that humanity has never possessed the means to measure. We may not be witnessing a mountain melting. We may be witnessing the opening phase of an event that could reshape the surface of the planet. What is terrifying about Everest is not what is melting away, but what may be preparing to break free from below. And the closing of the mountain may not be meant to protect humanity from it, but to prevent us from witnessing a physical process that no scientific model can explain and no technology can stop.